Okay, looking at part A, it looks like we will need to use general properties of integrals back from right when we first learned about integrals. So I know in general that the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx is equal to the integral from -6 to 5 of f of x dx. And looking here, we know that the integral from -6 to 5 is 7. And we know we're trying to find the integral from -6 to 2. We're left with this middle integral here, and conveniently, we have a graph. Since the integral is just the area under the curve, let's find some areas. So first we have this triangle here, and this is 1/2 times 1 times 1, which is 1/2. It also appears to be half a square. This is actually the same size, but since it's underneath the x-axis, it's negative. So 1/2 minus 1/2 is nothing, so we can pretty much ignore those. They won't really do anything for us. Now we have this triangle here. The area of this is 1/2 times a base of 1/2 times a height of 1, depending on your perspective, which is 1/4. The reason why we know this occurs at 1/2 and not somewhere really close to it is because this line has a slope of 2. Up 2 over 1, up 2 over 1, because we for sure know that there's a point at 2, 3, because it's given to us. So since it's a slope of 2, we can go up 1 over 1/2. Then looking at, we have another triangle. And the area of this triangle is 1/2 times a base of 1.5 or 3/2 times a height of 3, which is 9/4. So far the two areas we have that matter are 1/4, 9/4. Not sure about the color combo with the green and the pink, but I'm going to go with it for now. Now we have this space here. And there's not really a way to calculate this directly. It's kind of like a triangle, but one of the sides is, curved, like a right triangle with a curved hypotenuse. It's not going to work. However, I do know how to find the area of this square. That's not a good line. Ignore it, please. The area of this whole square is 3 times 3, which is 9. And the area of this right here, this is a quarter circle because conveniently we're told. And the area of the quarter circle is 1/4 for the quarter part times pi r squared, or times pi times 3 squared, which is 9 pi over 4. So then the area of that light blue kind of unidentified shape is 9 minus 9 pi over 4. So there's our three pieces, the highlighted in pink. So now, go back down here to our integral, and the integral from -2 to 5 of f of x is, let's see, -1/4. Lost my negative somewhere with that one. -1/4 since it's below the x-axis, plus 9/4. There's this one, plus 9 minus 9 pi over 4. So now it's, straight up algebra essentially. So we know that the integral from -6 to 2 of f of x plus, we simplify this a little bit, -1/4 plus 9/4 is 8/4, which is 2. 2 plus 9 which is 11. So we're left with 11 minus 9 pi over 4. Oops, I lost my dx. And this is equal to 7. We subtract this portion here on both sides, we end up with the integral from negative 6 to 2 of f of x dx equals, well, 7 minus 11 is negative 4. Then we can add 9 pi over 4. So we get negative 4 plus 9 pi over 4. Let's look at part B. Now we want to evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 dx. Once again, we start with just basic properties of integrals. So I'm going to split this, and this is actually 2 times the integral from 3 to 5 of f prime of x dx. So I'm splitting this piece, plus the integral from 3 to 5 4 dx. Okay, let's kind of solve it. Do a little bit before even looking at the graph. The 2 stays, and the integral of a derivative, well, they cancel each other out, right? So this is just f of x from 3 to 5, plus the integral of 4 is 4x from 3 to 5. So this ends up being 2 times f of 5 minus f of 3 plus 4 times 5 minus 4 times 3. So we have 2. Now what is f of 5? Well, conveniently we have the graph of f. F of 5 is 0 minus f of 3. Oh shoot, I don't know what that is. Yes, I do. It's 3 minus root of 5. Never would have guessed that one, right? 0 minus 3 minus the square root of 5. Plus, this up here is 20 minus 12, which is 8. So this is 2 times negative 3, distribute the minus sign, plus square root of 5, plus 8. Almost there. Negative 6 plus 2 square root of 5 plus 8. So we get negative 6 plus 8, which is 2 plus 2 times the square root of 5. Part C. So here's g of x, the integral from negative 2 to x of f of t dt. We want the absolute maximum on the interval from negative 2 to 5. Conveniently, it's from negative 2 to 5 because that's where our graph goes. Let's see what we can do here. So if g of x is that, if we want the maximum of g, to find extreme values, you need to take the derivative. So let's do that. G prime of x is the derivative of the integral from negative 2 to x f of t dt. Oh, this looks like a rule. Well, the derivative of the integral, we have an x up here, so this is just going to be f of x. So g prime of x is actually just equal to f. How convenient. So g prime of x equals 0 when f of x equals 0. And now we look at our graph. So f of x is 0 when x equals negative 1, 1/2. We talked about for the prior problem why that's 1/2. And 5. Now, it's an absolute maximum. So now at this point, what's the biggest? Negative 1, 1/2, or 5? 5. So the absolute maximum value of g on negative 2 is less than or equal to x is less than or equal to 5 is 5. Part D. Limits. Doesn't love a limit. Perhaps lots of people. I'm not sure. Actually, lots of people probably don't even know what they are, but we do. Lucky us. Okay. Zoom in a little bit. A little blurry. That's okay. So here's what we have. The limit is x goes to 1 of that lovely thing. First step with limits. Plug in the 1, see if we can get anything good. So if we plug in a 1, we end up with 10 to the first power minus 3 times f prime of 1 over f of 1 minus arctangent is the same as inverse tangent, which we write this way. And this is equal to 10 minus 3. Now, keep in mind I lost the limit notation, or got rid of it on purpose, rather, because we plugged in the numbers, number 1, so we don't need it anymore. So f prime of 1, well, it's the derivative, or the slope of the tangent line at this point. This line has a slope of 1, 2, 3, 4 over 2, which is 2. So f prime of 1 is 2. Now we have f of 1, which is 1, minus the inverse tangent of 1, or for which angle is the tangent 1. That's pi over 4. So now we can simplify this a little bit. We get 10 minus 6 over 1 minus pi over 4. 4 over 1 minus pi over 4. Since it's calculus, we don't need to simplify it or make it look any prettier.